Good evening and welcome to my video about complex fractions. It's about 6:40. I'm still in my classroom recording these videos for you guys. Please take a second and appreciate the San Francisco 49ers logo in the bottom left corner. Just want to let you guys know who is going to win the Super Bowl as we move on. So let's just keep going. There we go. A complex fraction is, let me get this set. A complex fraction is just a fraction that has fractions in it, for the most part. That's really what that says there. Let me give you some examples of a complex fraction. Notice here you have fractions inside of a fraction. They look something like this and they look something like that. We'll get into these ones a little bit later, maybe in class. There's two different methods to actually simplify these complex fractions. Let's go over both of the methods and you guys pick which one you like. The first method is to really just take care of the top and take care of the bottom. Then after that you simplify more, so basically you just divide. Let's take that same complex fraction we had on the last slide that looks like this. So what I mean by take care of the top is let's just subtract these together. So if in fact we subtract these first, we need the LCD, right? LCD obviously is 12. So in order to get 12, I have to multiply that by 2 and multiply that by 2, right? In the denominator, this is just like 2 over 1. So my LCD of the denominator is 9. So I have to multiply that by 9 and multiply that by 9. So once I do that, I should end up with a fraction that looks like this. The 1 times 2 is 2, so 7 minus 2 over 12 here. 9 times 2 is 18, so 18 plus 4 over 9 in the denominator. So as I simplify a little bit more, notice 7 minus 2 over 12, that's going to be 5/12, and the top is going to be 22 over 9. Now when you get to this part, remember it says to just divide. Remember the rule for dividing fractions is to flip the second one and multiply. So you should end up with a multiplication problem that looks like that. So really things just got a lot easier here. You have 5 over 12 times 9 over 22. And notice that these right here can cancel. This becomes a 3, that becomes a 4. It makes it a little bit easier to show that it's 15 over 88. Easy enough, right? Let me show you the second method. The second method basically is to just multiply the numerator and the denominator by the LCD of all the fractions that are in the problem. Some people like this way better, some people like the other way better. Let's actually do the same exact complex fraction and let's solve it this way. Now notice our denominators are 6, 12, and 9. So if in fact I take those three numbers and I try to find the LCD of each one of them, so the lowest common multiple of each one of them, what I'm going to get from my LCD, you guys can work it out, but I'm going to get LCD is 36, if in fact I work that out. So what I'm going to do is I'm going to multiply the top and the bottom by 36. What that's going to do is that's going to get rid of every last one of my denominators. So it's going to get rid of every last one of the denominators. 36 and the 12, that means you're multiplying this top by 3. 36 and 6, you're multiplying this by 6. 36 and 9, that means you're multiplying this by 4. And notice with this 2 right here, that's just going to become 72 when we do it. So your next result should look something like this. So remember, our denominators are gone. So we're going to have 21 minus 6 over 72 plus 16. And once we do that, we end up with the same exact value of 15 over 88. So either way you want to do it is fine. I have my own personal preference, and you can have your own personal preference as well. So let's keep moving, and I'll show you the different versions here. So let's solve both of these and see how it actually works, just to see if in fact which one you like. On the side, I'll use the first method. I'll take care of the top and I'll take care of the bottom. So this fraction right here, notice that the common denominator here, this is really z over 1. So z over 1 minus 1 over z. Least common denominator is z, right? So I'm going to actually multiply this. I'm going to multiply this by z over z. right? Just to get that. And then I'll have common denominators, right? So that means this is going to be z squared over z squared over z minus 1 over z in the top. And in the bottom, I'm going to have z once again. This is 1 over 1. Once again, z is my denominator. So I'm going to multiply by z in the bottom. That means I have to multiply by z in the top. And that should give me z over z minus 1 over z. So that actually, when I combine my fractions, that means I have z squared minus 1 over z over z minus 1 over z. Now, once I get to this part, remember that this is a division problem between two fractions, so really I'm multiplying them by each other, right? So that's really like I'm taking the z minus 1 over z, and I'm bringing it up here as z over z minus 1, and I'm multiplying. It's the same exact thing. I'll write the actual multiplication problem down here a little bit bigger. That's z squared minus 1 over z times z over z minus 1. Now notice here what cancels, right? This cancels with this. And do you notice something about this z squared minus 1? That can actually be factored to be that. So since we did that, this cancels with that, and all I'm left with is z plus 1. And I'm done with that part. So let's do it the other method and see if in fact you like it that way. Now notice the least common denominator in method 2 for the top is z. And well, for the entire thing, the least common denominator is z. So what I want to do is I want to multiply this fraction right here by z. And I want to multiply this by z. Remember, I'm multiplying by my LCD. So if in fact I do that, I should end up with z squared minus 1 on the top and z minus 1 on the bottom. Once that's factored, you have z plus 1 times z minus 1 over z minus 1. And these cancel. So I'm left with the same thing. I'm left with z plus 1. So either way that you want to do it, that's perfectly okay. Let's actually try this one. So try this one on your own and then match up your answers with mine to see how you did. So pause the video right quick. Do these problems in whatever method you want to do. So just do one of these, which they're the same thing, and match up your answers with me after you come back from the pause. So pause the video right now and then work it out and then come back. This is what my work looks like when I was finished with it. Notice in the top, this time it looks like it was easier to do method 1 as opposed to the other problems we did. It looked like method 2 was easier. So if in fact we go through this one, I just took care of the top as I went along. I got t plus 1 over t minus 1. Now this one was a little bit more complicated because my LCD in this case was t minus 1, t plus 1. So I ended up with a problem that looks like a lot like problems you've seen before. Now notice in this one right here, I have common factors in two terms. I have t plus 1. Whoops, let's get out of here. I have t plus 1 and t plus 1 right here. And in the bottom, I have t minus 1 and t minus 1. So what I did is I just factored that out. And once I factored out, I'm left with this stuff inside. I got to cancel that, and I was left with the same thing, t plus 1, t minus 1. So it doesn't matter which way you do. Whatever way you like to do it, that's the way you can do it. My preference usually is the second one, but in this case, obviously the first method was easier. We'll just do some more of these in class. All right, that's the end of this video. Go Niners.